Suppose you're interested in calculating the integral from 0 to 3 times square root of 3/2 of x cubed divided by 4x squared plus 9, which is raised to 3/2 dx. Let us use the method of trig substitution. I'm going to take x to be a coefficient of tangent function. So let us take x to be equal to 3/2 tangent theta. Very well. So what is dx? If I calculate dx, dx is 3/2 times secant squared theta d theta. So let us begin. We need to plug this into the integral and simplify as much as we can. For now, I'm going to leave the boundaries empty, and then at the end, I'm going to do the substitution. This guy can be written as 3/2 tangent theta to the third power, and on the numerator, I have dx, which is nothing but 3/2 secant squared of theta d theta. Let me move this a little bit further here to avoid any confusion. Divided by, down here, you have 4x squared. So you have 4 times x, which is 3/2 tangent theta to the secant plus 9, all raised to 3/2. This integral in turns can be written as 9/4 tangent to the third power of theta times 3/2 secant squared of theta d theta divided by, well, on my denominator, I have 4 times 9/4 tangent squared of theta plus 9, all raised to power 3/2. So pay attention here. I can get rid of 4 and 4, and then I can factor out 9 as well. So that's why we select 3/2 tangent theta. This guy in turns can be written as the integral of, if you do the multiplication, you have 27/8 of tangent to the third of theta times secant squared of theta d theta divided by, now inside parentheses, you can factor out 9. You get 9 to power 3/2 of tangent squared of theta plus 1 raised to power 3/2. Very good. We're doing a lot of algebra here, everybody. This guy can be written as the integral of 27/8. You have tangent to the third power of theta times secant squared of theta d theta. And now on the denominator, 9 is 3 to power 2. So you get another 27 down here. And then tangent squared plus 1 is equal to, as you remember, is secant squared. So you have secant squared raised to power 3/2. Very good. You can cancel out 27 and 27. The exponents, they get canceled out. So you're left with secant to power 3 on the denominator. Then you can simplify these two as well, and you get secant on the denominator. So this integral is 1/8, the integral of tangent to the third power of theta divided by secant theta d theta. Very good. So tangent, as you remember, is sine over cosine, and secant is 1 over cosine. So we can move on and simplify this further. This is equal to 1 over 8, the integral of sine to the third of theta divided by cosine to the third of theta over, and secant is 1 over cosine theta and then d theta. So let us simplify this further. You get 1 over 8, the integral. You can get rid of 1 cosine and 1 of the exponents. So you get 2. You have sine to power 3 of theta divided by cosine squared of theta and then d theta. So, okay. Now, as you can see, you have powers of sine and cosine. What you can do, you can break this guy down into 1 over 8. Let me make sure I wrote this guy down correct. Oh, I forgot to copy this guy down. Okay, 3 halves. Okay. Yeah, guys, I forgot to write down 3 halves. So let's just add 3 halves before we go further. So we get 3 halves as well. Perfect. Times 3 halves. Forgot to copy this guy down. Very good. So you have the integral of sine theta times sine squared of theta d theta divided by cosine squared of theta. This is equal to 3 over 16 of the integral of sine theta 1 minus cosine squared of theta divided by cosine squared of theta d theta. Very good. What you can do, you can say that, hey, I'm going to take u sub here. U is equal to cosine theta. So my du is negative sine theta d theta. So this integral becomes negative 3 divided by 16 of the integral of, so this is part of my du. So this is negative du. So you have 1 minus u squared divided by u squared and then du. Now this integral is negative 3 over 16 of the integral of 1 over u squared minus 1, then du. Very good. This can be written in terms as negative 3 divided by 16 of negative 1 over u minus u plus constant of integration. But what is u? U is cosine theta for now. So you have 3 over 16 times 1 over cosine theta. And then let us keep 3 over 16 outside the parentheses. Just distribute the negative sign plus cosine theta plus constant of integration. Perfect. So now let us go back to what we did at the beginning. If I go back up here, let's take a look. We had the boundaries for our x, all right? I'm going to take this guy and copy it down here. And my x was bounded between, as you remember, between 0 and 3 square root of 3 divided by 2. So if x is equal to 0, 3/2 tangent theta is equal to 0. So tangent theta is equal to 0. It means that my theta is equal to 0. So I found the lower bound. If I want to just keep taking the integral, my lower bound for theta is equal to 0. Now if x, so this is my theta equal to 0 down there. If x is equal to 3 times square root of 3 divided by 2, 3/2, tangent of theta is 3 times square root of 3 divided by 2. If I cancel out 3 and 3, my tangent theta becomes 2 times square root of 3 divided by square root of 2. And if I just rationalize this, I can get rid of these two, right? I'm trying to find the value for my tangent. Can I simplify this further? Let me see if I can simplify this guy further for you. So let's see. I think we need a calculator if you want to do the change for the boundaries here. The lower bound is 0. We don't have any issue with it. So by inspection, if my x is equal to 3 times square root of 3 divided by 2, 3 times square root of 3 divided by 2 must be equals to 3/2 tangent theta. If I cancel out 3 and 3, tangent theta is equal to 2 times square root of 3 divided by 2. Is this 2? Oh, okay. This guy is not inside the radical. Okay. Let me fix that. This is not inside the radical. Just 3 is inside the radical. Otherwise, we had to use a calculator to do the calculations. Okay, perfect. Make it much more easier for us. Okay, square root of 3. So this is square root of 2 is not inside the radical, everybody. This is just square root of 3. That's why we can easily get rid of that and find the other bound. So this is square root of 3 divided by 2. That's how you can get rid of 2 and 2. So tangent theta is equal to square root of 3. It means that your theta, the second bound, is equal to, well, you have pi divided by 3. Very good. So we found the other bound, which is pi over 3. Now we can just substitute these. You have 3 over 16, 1 over cosine of pi over 3, which is 1/2, plus cosine of pi over 3, which is 1/2, minus, if you plug in 0, you get 1 plus 1. So here you have 3 over 16, 2 plus 1/2 minus 2. So you get 3 divided by 2 times 16, or 32. Very good. So let's go back to our question. Just make sure I wrote it down this way, and I made a mistake myself. This is not inside the radical. These are the steps in calculating this long integral using u sub, using trig substitution,